The Chatelier's principle states that when adding stress to a system that is at equilibrium, the system will shift the opposite way to reestablish equilibrium.
So here we drew a seesaw to represent Le Chatelier's principle and the fact that over here there is more weight, so it's shifted downward, but it's going to shift this way to reestablish that equilibrium and make the seesaw level again. We have our practice problem, which is CH4 plus 2H2S is equal to CS2 plus 4H2 plus heat. So right now, this equation is at equilibrium. But when we add pressure, the pressure increases on this side, and therefore it will shift this way. Because right now the weight is heavier on this side, so the arrow will be going this way. And the pressure is more on this side because you have to look at your coefficients, and here we have 1 plus 2, which gets you 3, and 1 plus 4, which gets you 5, and 5 is greater than 3, so therefore it would need to shift this way since the weight is heavier on this side. So now for CS2, which is carbon disulfide, if you take that away, it's like you're taking a piece of this away. A child is getting off the seesaw, and so the weight would go this way, so you would need to push this way to make it equal. And over here, if you add heat, heat's already over here, so you're adding to this side, and so the equilibrium will need to shift this way. It would need to add weight over here. So, and then if you took away CH4, which is over here, the weight would be less on this side and more on this side, so you'd need to shift the weight over here. Or, I'm sorry, over here. And then, same, if you remove H2 from this side, you would be decreasing the weight over here, so this side would be heavier, and you would need to push more weight over here. Causes the arrows to go that way.
Okay, so these are our practice problems. Just pause the video and write them down and do them. Yeah. Okay, so when you increase SO2, and SO2 is on the right side of the equation, so you're putting more weight on the right side, so equilibrium has to shift to the left side. And when you increase the temperature and heat is also on the right side, which adds more weight on the right side also, so equilibrium has to shift to the left side to create equilibrium. And when you decrease the pressure, you focus on the number of moles, which are the coefficients. And we have 3 moles here, and we have 3 moles here. So there is no change in between, since there is no number greater or less than either one. Yeah. And for when you increase the pressure, you also focus on the number of moles, which are the coefficients, and they're the same number on each side, so there's also no change. And when you increase the volume, you decrease the pressure, which also has no change since it's the same number of coefficients on both sides. And for this one, when you increase H2, and H2 is on the left side of the equation, so it adds more weight.
Right? It's on the right side. It's on the right side. It's on the right side of the equation.
Oh, I'm sorry, did you pause that?
No, just continue.
Oh, okay, so H2 equation, so it has to shift to the left. And when you increase the concentration of H2O, and H2O is on the left side of the equation, so equilibrium has to shift to the right. And when you decrease pressure, there's no change because, once again, you focus on the number of moles. There's 1 mole here, 1 mole here. There's 2 moles on the right side, and there's 1 mole here and 1 mole here. So there's 2 moles also on the left side. So there's the same number of moles on both sides. So there's no change. And when you decrease CO2, and CO2 is on the right side, so you're decreasing, which is making it less on this side, so you have to shift to this side. And when you increase pressure, heat is on the left side. So when you increase temperature, I'm sorry. When you increase temperature, you're adding more on the left side, so equilibrium has to shift to the right. And when you decrease temperature, the temperature is right here, you're taking off from the left side, so equilibrium has to shift to the left to add more to it. And when you add a catalyst just increases the rate of the reaction, so it has no change on either side.